By this point, you should have a pretty good idea of how to factor the difference of squares. And, as a little refresher, part of that is identifying whether or not it is difference of squares. So, again, you can tell if it's difference of squares if, firstly, there's two terms with a subtraction sign in between them, and you can take the perfect square of both of the terms. So, to do this one, the square root of 4x squared is 2x, and the square root of 9 is 3. One gets a plus and one gets a minus. Now, part of the process of factoring difference of squares is actually identifying what is a difference of squares. And when they're kind of normal looking, it's pretty easy. On this example, you have to be able to identify this as the base, and it's being squared. So actually, this can be looked at as one term minus another term. So this is actually a difference of squares problem. And I'm just going to run through a couple examples of these just so you know what to do when you see them. And again, the big deal is identifying this as one term. Since the square is on the outside, when we take the square root of this term, we're just left with what the base is, just like any other square. Like, for example, kind of a little side note here. When we take the square root of x squared, the square root and the squared kind of cancels themselves, and you're just left with what the base is. So that's the same idea as what we're going to do with this problem. Once you identify this as a difference of squares, the process is identical to, any other difference of squares problem. You're going to take the square root of both of the terms. And again, when you take the square root of the quantity of x plus y squared, you're just left with the base of x plus y. And I would leave it in parentheses for this kind of problem. So we would have x plus y and x plus y, since that's the square root of the first term. We'd have the square root of 9, which is 3. One gets a plus, one gets a minus. And, you should always check to see if there are things that you can simplify, and none of these are like terms, and so we can just leave it like this. So this will be slightly different because we don't have two variables inside of this first term. But again, this is another difference of squares problem. Here's a perfect square term minus another perfect square term. So we're going to take the square root of both of them. And again, square rooting this quantity, since it's already squared, is just going to leave you with the base, which is x minus 2. Square root of 16 is 4. One gets a plus, one gets a minus. Now, in this case, we do have something that we can simplify a little bit further. There's really no need for these parentheses inside here. And so we could rewrite this as x minus 2 minus 4 times x minus 2 plus 4. And so our final answer would end up being x minus 6 times x plus 2. Now there's no real difference between this problem and the last problem, except for our quantity is after the subtraction sign, so that's going to kind of change how we simplify. So you just have to be careful. Anytime you have any kind of polynomial or any problem really that has negative signs or subtraction signs with them, you just got to watch out for what you're doing. But again, this is a difference of squares problem. We have a perfect square minus another perfect square. So when we take the square root of 25, we get 5. When we take the square root of the quantity x minus 7 squared, we're just left with x minus 7. One gets a plus and one gets a minus. Now again, we can simplify a little bit because we do have like terms in here. But you definitely have to be careful about the subtraction sign. So, it's always better to write out more steps than less steps. So if you distribute that negative sign, you would have 5 minus x plus 7 and 5 plus x minus 7. So now when you combine like terms, you would end up getting 12 minus x times negative 2 plus x. So just be careful with subtraction signs.